Welcome to New Thinking for a New World, a Telberg Foundation podcast. I am Alan Stoga, your host. Each week, I bring you conversations with people who think differently about the great issues that are shaping our world. Geopolitics, disruptive tech, mass migration, the changing climate, culture wars, all of it is grist for our mill. I hope you enjoy listening. I also hope you will let me know what you think and that you join the conversation at telbergfoundation.org. And now for today's episode of New Thinking for a New World. The Arctic is increasingly warmer, wetter, and greener, which sounds like a great description of the Caribbean, but not of the far north. Key Arctic vital signs, sea and land surface temperatures, terrestrial snow cover, the pace at which the Greenland Ice Sheet is melting, the extent of sea ice are all heading in the wrong directions. In fact, the Arctic is warming 2 to 3 times faster than any other place on Earth. We used to think about climate change as sort of a slow motion car crash, but that metaphor dramatically understates the pace at which the whole planetary system is changing. And ground zero is the Arctic. Tero Mustonen knows the Arctic. As a scientist, as a fisherman, as a leader of the innovative Snowchange Cooperative, as head of the village of Selkie in North Karelia, Finland. Welcome, Tero, to New Thinking for a New World.
Thank you, Alan. Once again, great to be back.
Before we get started, I should add that Tero is also a past winner of the Telberg SNF Eliasson Global Leadership Prize. What's happening in the Arctic is well documented in NOAA's recently released Arctic report card. Tero, what stands out for you in this year's annual report?
When we went into the writing of the report card, one of the things that started to stand out was the shifts that are going on in the summertime. So a lot of the past, whether it's IPCC or some other assessments, have been looking at how the winter conditions and global mean temperature has been affecting the Arctic. Here, this year, we had tangible evidence of the fact that past summer, was the warmest on record since the measurements started. And in some ways, to myself, this was really about the massive shifts that's going on in the summertime in the Arctic.
What is the consequence of that kind of summertime warming? Why do we care?
Well, temperature is really significant driver for fire. And I think for example, in North American Arctic, Canada, Alaska, Northern Boreal, and into the tundra, one of the huge shifts we saw this year was the over 4 million hectare fires that burned in Canada. I was traveling across the region in late summer into the autumn on my field mission, and in some ways the end was in Minnesota. That's the end of the boreal forest, and you could still smell the fires from further up in Canada. We also witnessed evacuations of large northern cities like Yellowknife, Inuvik, Hay River, and others. So this was the summer when people really had to go also in the inland towns and areas because the fires became so big. And once you have that going on, all of the fire, of course, constitutes also a new driver or adds to the CO2 levels in the atmosphere and affects also permafrost, the permanently frozen ground.
You mentioned temperatures, and of course we tend, because we're humans and live on the land, to think about land temperatures, terrestrial temperatures. Clearly, sea temperatures are also increasing. I've read somewhere that the algae blooms in the Bering Sea are becoming an issue. Well, how should we think about that?
Well, that's a very good question. Not all of you listeners may have traveled to the Bering Sea or been visiting these remote areas, but essentially what's going on between the North Pacific, which is the largest ocean in the world, and then Bering Sea, which is sitting between Siberia and Alaska, is that there has been for a long time a kind of a cold water, we call it the wall. So it separates more temperate species and the waters of North Pacific from the colder Bering Sea. And in 2018, for the first time in a massive quantity, warmer waters entered into the Bering Sea. This led to something called algae blooms. So essentially what's going on is that once you have more nutrients, you have warmer waters, they enter into the northern waters and they start to produce more. And therefore, these algae blooms affected everything in the region post 2018. That season was especially quite bad. We had bird die-off events. It affected a lot of the salmon over there in Bering Sea and also marine mammals. So there's a fine balance between how the North Pacific behaves and then further up when you go to the Bering Sea area. And now this cold wall of colder water was breached about 5 years ago, and every once in a while it has then happened again. So that's kind of a shift that's going on where the blooms of algae, the primary production, are then cascading down in the food chain and affecting pretty much everything from seabirds into fish into mammals and so on and so on.
And when you say affecting, it can be good or bad in a sense that mammals, fish, birds that will replace existing mammals, fish, birds that were indigenous to this area when it was uniformly cold, or is that incorrect?
Well, there's all sorts of algae, and one of those, what we really look at carefully is the harmful algae bloom. It's called HAB, and that's kind of dangerous because it's producing something called saxitoxins, and they are affecting shellfish. They're causing shellfish poisoning, and that's also affecting animals and humans. And that's why you have a number of different algae or so-called harmful algae blooms, and they are then accumulating in zooplankton and further into marine mammals. And these toxins are moving in the food web, and they are affecting wildlife at all levels, and including those that don't directly consume shellfish or some of the other marine species. So it's a very complex moment in time where people sometimes talk about regime shift. And in plain language, what these kind of drivers that we are witnessing in the Bering and North Pacific really talk about is that you have had a pretty stable ocean system for the thousands of years in the past, and now you have warmer waters, you have new primary production, you have kind of shifts in the way food and energy travels in the system. And some of those are harmful both to humans and wildlife. And for example, humans can be exposed to these toxins when they eat these animals, fish and others, including shellfish. And a lot of those coastal communities around Bering Sea area are still dependent on food security. These are very remote fly-in communities, both on the Russian side and the Alaska side. And that's why the reliance on ocean foods, for example, marine mammals and salmon, is high. And whatever happens to the system then accumulates and kind of tends to influence also human health and food security.
Is that kind of transformation of the ecosystem reversible? Or have we gotten to the point where once that cold water wall was breached, it has been breached? And it's a question of how fast and how this plays out.
Well, the clear answer, we don't know. We know that the ocean has been soaking up a lot of carbon. All of what we have been producing, for example, through our industrial revolution, and since that has been pretty much seeping up in the oceans. So the oceans are a huge sink that has been storing energy from the atmosphere. On the other hand, the Arctic is kind of the cooling system, or sometimes called the bridge of the whole planet. And it's a complex place. You have, for example, here in the region we are discussing the Bering Sea, an interplay between three very large systems. You have the North Pacific entering into a very narrow strait, the Bering Straits, and then opening up into the Central Arctic Ocean, Eastern Siberian Sea and east towards the Beaufort Sea. And the way the ocean currents are traveling, the makes these even more complex in the sense that you have the top waters and then you have the bottom waters that are warming up and behaving differently. So the wall that was separating this cold water wall, so to speak, has been rebuilding in the past few years, but it's also let other algae blooms in. And the best answer to the question what can be done is, of course, to first enable rigorous monitoring. So we need the facts. We need the things that tangibly tell us what's actually happening in the food chain and also in the human communities, especially things like toxins in marine mammals. We have to bear in mind that the Bering Sea and North Pacific are some of the most productive fisheries in the world. This is also what the Arctic Report Card talks about. We have two kind of a divergent pathways for salmon. One of the keystone species in the region, you have Bristol Bay, which is in the more southern part of the system, and there you have excellent fishery. The salmon is booming. It's doing really well. And just a few 100 miles north in the Yukon area, where the Yukon River empties into the Bering Sea, you have a number of Pacific salmon species that are doing very poorly. Actually, the king salmon, for example, is doing really, really bad. We might be looking at an extinction event for some of those spawning rivers. So, summary, what can you do besides climate action and trying to do the big control on temperature, which is one of the biggest drivers of these changes, is also monitoring. We need systematic on-the-ground eyes on sea ice, algae blooms, water quality, the key species, and then also kind of a rigorous Bering Sea observation that combines all of these things and makes a good recommendation for decision makers. Of course, there's a number of other things you can try to do. You can switch into a more sustainable energy sources in the remote villages, or you can control coastal erosion by putting this kind of a safety measures in place like the Army Corps of Engineers has been doing. But if you really want to address the ocean change, you really have to talk about the temperature as well and the kind of use of marine space. How much are we conserving? How much traffic is going through the Bering Straits and the region? And how much are we using the resources out there in Bering Sea, like salmon and the other fisheries?
When you say we, that raises governance questions. There are a number of nations who border the Arctic. There are others who have deep interest in the Arctic. How are decisions made on some of the issues that are rapidly evolving in that part of the world? Who's in charge?
If you would come back to this question 2 years ago when we last spoke, I'd have another answer. Of course, the war in Ukraine, where Russia has invaded Ukraine, has tremendously changed geopolitical order in the Arctic. Before 2022, we used to have a very good system called Arctic Council. This was consisting of the 8 Arctic countries. So you had all those countries that surround the Arctic Central Ocean, including here, Finland, Norway, Sweden, and so on. Then you had a number of indigenous peoples organizations and other NGOs participating in the science and management and decisions on soft policies. It wasn't the forum on military, but it was a very successful body for science and sustainability and other kind of rather progressive decisions. Now it's back to a place where the large countries tend to dominate. So you have a lot of security issues back in the Arctic. Russia is building up a lot of military ports. The US has been financing quite heavily into the Alaskan security file. And people talk about the new icebreaker fleet and these kind of things. So I would say that we are in a kind of a in-between moment where the Arctic is being shuffled again, so that you have the big countries looking at how does competition look like, and then you have a large number of new parties, China, even Singapore, India, and China calls itself near Arctic country. And of course, China will continue to have vested interests in the fish, minerals, transport corridors, because one of the things we are witnessing now in the post-2022 context is the fact that the Arctic will remain a source for a lot of the rare earth metals and other resources that are needed for the big green transition that everybody talks about. So there's kind of a big vested interest in the resources. And at the same time, you have some parts of the Arctic where the indigenous peoples, for example, have a land claim, which is pretty historic. So there are also indigenous governments that are having a big say, for example, in Nunavut, northern Arctic Canada, and parts of Alaska.
Thanks for listening so far. I hope you're enjoying the conversation as much as I have. If you haven't already, please subscribe on the platform of your choice and rate us on Apple Podcast. Now back to today's discussion, sponsored by the Stavros Niarchos Foundation, SNF. It sounds like there is an emerging conflict between the primacy of national security and defense interests, in part because of the Ukraine war, and the scientific agenda, which demands collaboration, cooperation, regardless of borders. It's early, as you said, 2 years ago, your answer was different, in fact. But that must concern you, that the risk that science and the issues that you are so concerned with might be pushed to the background, or are being pushed to the background in this geopolitical context.
Well, there are basic facts why the Arctic matters and why should we be studying it closely and in good new partnerships, for example, with the indigenous communities, because they are kind of first responders. You have fishers out in St. Paul Island, which is a very small, the Diomedes, they are a small group of islands in the Bering Sea and North Pacific, and they are able to observe, for example, things like rare short-tailed albatrosses, whether it's a bird or other ecosystem species that we know very little of. And I mean, universities and scientific expeditions out there will always happen mostly in the summertime, or they are limited in time. So the engagement with the actual people that are living in the Boreal and the Arctic is very vital. And now with the war, the largest component of the Arctic is cut out of that scientific collaboration, Russia. So we don't physically know. I can't go there, even though I have been traveling and working there for 25 years now, before the war. So we don't know, in fact, how things are going on at the East Siberian Sea. We don't know how things are at Yamal or some of the other flashpoints of the existing Arctic drivers that are affecting the region. And as the saying goes nowadays, whatever happens in the Arctic doesn't stay there. So people may think it's all polar bears and Inuits and whatnot, but the interconnection between the climate, the oceans, trade, economy, resources, and now geopolitics makes the Arctic kind of a tuning knob for the whole planet. If we lose the Arctic, for example, in terms of ice cap or permafrost soils or whatever the case, the consequences will not be limited there. They will directly affect things like monsoon rains. Also, Antarctic matters here quite much, and so on and so on. So sometimes talking about the Arctic, I try to say that perhaps in 1980s, the scale mattered. It was very far away, and there was all sorts of stability processes going on. It's no longer stable. So that's why it matters to everybody when you turn on your gas-powered vehicle in New York City, you are affecting something that happens then in the Alaskan oceans, even though it's far away as we think about it.
Let me ask what may sound like a trivial question. The first time I was in northern Greenland, I remember asking someone who lived in Greenland, who's a native of Greenland, what had changed in his lifetime. And he immediately said mosquitoes. When I was a kid, there were no mosquitoes in Greenland. It was too cold. And then he told me that the seal meat was sour and that literally the taste had changed over his lifetime. You live in the Arctic. You work in the Arctic. You are a native. What stands out as you think about, in practical terms, things that for you are markers of the transformation?
Well, I think the speed and scale of change, like we can have this endless list of the doomsday topics that people get really tired of, and that's perhaps not the very, very topical thing to always replicate and repeat. However, what we can say is that when you have something that burns in the order of 4 million hectares, like in Canada, the boreal forest and the northern forest, that matters. These are areas that have never happened before, events that have never happened before in that scale. The other thing that really stuck me this year is that on this side of the north, I'm in a Finnish boreal village, and then as I go for work in the high Arctic or in 69 degrees north, for example, in these Atlantic salmon rivers where the Sami people are living, we saw in the order of hundreds of thousands of invasive pink salmon coming to these Atlantic salmon rivers. And they are now in some ways more successful in spawning and proliferation. They were introduced by the Soviets in 1900s, but they have now started to proliferate in thousands of Atlantic salmon rivers in the European north, all the way to Iceland, eastern seaboard of the US and Newfoundland, in Canada, and so on and so on. So when I look at the pink salmon, that's the invasive Pacific salmon that's spreading here. I'm looking at something that reminds me of the fact that you had thousands of years of stability in the Arctic systems, and now in a year, you almost have a complete switch of a primary fish that's in a river system from Atlantic salmon into invasives, or pink salmon in this case. They behave differently. The pink salmon will die after spawning. They are bringing a lot of nutrients from the ocean. They are causing potentially new diseases. There's a lot of potential eutrophication for these rivers and so on. Doesn't matter what the impacts are. The answer to your question is that I have borne witness, I think personally, to a very big thing I would never before believed in my own mind, in the sense that it's here, it's really affecting, and these systems are under big change. Now, it's not always negative. There are things we can still do, and it's late in the game, but it's not over. That's what I try to think myself.
And that's exactly where I want to go next. One of the things that you and your colleagues at Snowchange Cooperative are doing is piloting rewilding and ecosystem restoration, first in Finland, but potentially elsewhere as well. The landscape rewilding program. Let's talk about that a little bit. What's the problem, and how does landscape rewilding solve it, or potentially solve it?
Well, you have all of those big drivers we have been talking about. I'll just mention something that matters to the program, and it's to do with the fact that if we look at the carbon, so the carbon, which is so central to our fight against climate change, 1/3 of world's remaining ground carbon is in the northern peatlands and northern habitats. A lot of those permanently frozen areas, they're called permafrost areas, are also beneath the Arctic Ocean coasts. In fact, in the report card and some of the earlier studies, it has been pointed out that 2,800 billion tons of carbon is in the ocean permafrosts. That's 2 times more than in the permafrost on land. So one of the new discoveries we are doing is to find out that, my God, it's also in the oceans, in the coastal shelf, and we are witnessing some of the early thaw events regarding how this carbon is being lost, for the lack of better term. So the thaw is accelerating. And this is, of course, contributing to the whole temperature question and the global climate change, speeding of the climate change. Now, the question then comes, what can we do? We have the global policy where people are on and on talking about the fact of not being naughty and not polluting, and we have to limit this and that. What we don't talk about is that how can we store and start carbon sinks, for the lack of better term, using restoration. We call it landscape rewilding here. So the idea is that there's not much we can do on those permafrost-based peatlands and their thaw. But here in Finland, Sweden, Norway, parts of Canada, we have also non-permafrost peatlands that have been affected by human land use and some of the other industrial processes. They also are a massive sink and store for carbon. And there we have a window. We have a chance to enable restart of what's often called a nature-based solution. So it's not a trifle number of millions of tons of carbon that's still in those non-permafrost peatlands, and also action can be taken fast. So in the landscape rewilding program, we are trying to restore in order of 55,000 hectares. There are two basic functions why it matters, to make it as clear as possible. Those peatlands that are here and can be restored after human intervention are extremely important in carbon storing. They will keep that carbon on the ground for us. It will not be released to the atmosphere. So it matters tremendously. Even 800-acre area can store up to 1.7 million tons of carbon if you do things well. The second one is that those peatlands, if we are successful in restoring them, start to be carbon sinks. So they will actively draw down carbon dioxide. When people talk about the technical solutions to how do we capture carbon, how do we draw it down? Well, I have news for you. We have that already in place in those peatlands. And that's why when we are successful and advancing rapidly, it becomes a very big carbon solution, climate solution. It also restores habitat. So the Arctic, to conclude, will host millions of birds that will fly on the flyway from the south to nest here. And peatlands are of prime importance, especially in Finland, to host and nurture a new cohort or generation of waders, ducks, and many of the birds that will then fly south in autumn for new life. And that's why the peatlands are kind of the nexus of a solution. They will keep carbon on the ground, they will be storing them down from the atmosphere, and they are providing for life, like birds and all the other northern species that are here.
Let me, Tero, just clarify one point. These lands need to be restored because they had been overforested, overharvested, that the trees have been removed and not replanted. So you've got large open spaces from industrial forestry that, left to their own device, the carbon will escape. And what you're doing, and the Snowchange Cooperative are doing, is to rework the space, I assume replant trees and so forth. Rewilding is the phrase, but it means something different, I suspect, to the British than it does to the Finns.
Yeah, I'll be very short, but essentially what rewilding in the Arctic and Boreal means is that we want to get the natural functionality of an ecosystem back up and running. And as you said correctly, Alan, the use of these peatlands and some of the timber forests has been servicing our society. There, everybody knows IKEA. So a lot of the timber forests in the Nordic countries have sourced wealth and contributed to society. But they have come with a price that we have now discovered. A lot of those peatlands and boreal forests have been utilized by humans, and now we are in a place where restoration, rewilding can enable, through natural regeneration and blocking of the ditches in peatlands and raising the water table back to a safe level, restart these functions. And through that, unlike the Amazonia, the boreal forest is the largest ecosystem on the planet. And unlike the Amazonia, it can come back when we use, for example, things like natural regeneration and restart of a peatland functionality. In fact, peatlands are proving to be the second lungs of the planet. And that's why we are working so much, investing our time and interest in those areas, because they are, per capita, very intensively positive carbon store and a sink.
That's a terrifically positive story, because it isn't, as you said, just about scaring people into not eating meat or something. It's actually trying to restore the natural systems that have been destroyed. Last question. You're working on 55,000 acres, 50,000 hectares, which is an enormous chunk of land. How big is the potential? How much is out there to work on?
We could have a big breakthrough if we also combine conservation of these peatlands that are still remaining around Hudson Bay, for example. So in Canada, we have very similar, and Alaska, very similar ecosystems. If we are having a good land code that keeps them protected, and we are restoring these affected or disturbed peatlands, we are looking at millions and millions of hectares that could be worked on over the next 5 years. And therefore, we need kind of a Marshall Plan for the Arctic, because as we discussed before, to conclude, what happens in the boreal and the Arctic, the ice cap of our planet, I'll ensure you will not stay there. And therefore, if we are succeeding on this front, if we are making a breakthrough here, by the North, for the North, it's for everybody. We are cooling India, we are cooling Pakistan, we are cooling Sudan.
And that's why we're having this conversation. More people need to understand that it isn't just hand-wringing that needs to be done. It's actual work that needs to be done. And it's people, Tero Mustonen, like you, like your colleagues at Snowchange, that are doing it. But we need our governments to get behind it and move on this dimension, not just on the rest of their much more popular and perhaps sexy agenda. So thank you very much, both for what you're doing, but also for this conversation.
Thank you, Alan.
Thank you for listening to this episode of New Thinking for a New World. I'm Alan Stoga, podcast host, and I look forward to your joining our next conversation. Remember, tell us what you think at telbergfoundation.org.